Hey everyone, Miss Ross here. Welcome back to Mrs. Ross Does Math. Today's lesson is for Algebra 1B, and the topic of today is radicals. How can we add and subtract them together? Now remember, this is an optional unit, although I will highly recommend that you complete it, even just a portion of it, so this way you guys are prepared for what comes along next in geometry and Algebra 2. Let's get this started. So, once again, this is for Algebra 1B. Our topic is adding and subtracting radicals. Here we go. Our essential question: how are adding and subtracting radicals similar to adding or subtracting fractions? There happens to be one commonality between these two, and we're going to take a look at it now. So, for you, I have a little insert. It looks like this: adding and subtracting radicals. Here we go. We can only combine radicals that have like terms. Okay, so what this means is that if they have the same number in the radicand and they have the same index, then they are like. So, like radicals have the same index and the same radicand. Remember, that index is the number in front of our radical sign. So this right here is the index. And the number inside here, the number or number in variables, or just variables, is our radicand. Okay, so we want to keep those two pieces in mind. Oh, I'm going to give it a moment to adjust. There we go. That looks better. All right, so when we talk about adding and subtracting radicals, we are going to begin by simplifying everything first. Okay, so we're going to simplify everything first. Now, this is the part that's a little similar to fractions, okay? When you talk about adding or subtracting fractions together, they have to have a common denominator. When we add or subtract radicals together, they have to have the same index and the same radicand. So to combine like radicals, we are going to add the coefficients. Remember, those are the numbers in front of our root sign, and keep the same radicand. This is the same thing as if I had 5 sevenths plus 1 seventh. My sevens are going to stay the same, but the numbers in the numerator, the 5 and the 1, those would change and become 6. The same thing we're going to apply here. So, in our first example, we have 2 root 45 minus 2 root 5. So, let's break down 45. 45 can be broken down into 9 and 5, because 9 times 5 is 45. Then, my 5 is prime, so I'm going to circle it, but my 9 is not. 9 breaks down to 3 and 3. What this means is that I now have a pair of 3's that I can move to the front of my radical, and that's going to leave me with 2 times 3. Remember, anytime we move something outside of our radical, it gets times by what's existing there. So 2 times 3 is going to be 6. I'm going to be left with 6 root 5. Whoops. Made a mistake there. That's okay. That's what whiteout was for. All right, so once again, I get 6 root 5 because that 5 is remaining. Now I get minus 2 root 5. This 2 root 5, nothing can happen to it. So we are just going to bring it down. Now, my root 5 is going to stay the same. That is like my denominator in a fraction. Once it is the same, it stays the same. What's going to change, though, is the numbers in front. So I have 6 minus 2. That's going to leave me with 4. So my answer is 4 root 5. In example number 2, we got a couple of different ones here, so we're going to need to take a look at each one of these radicals as an individual, and then we're going to see if we can combine anything together. So, let's start out here. I have negative 3 root 12 plus 3 root 3 plus 3 root 20. So, let's start here. The root of 12 can be broken down into 4 times 3. 3 is a prime number, but 4 is not. 4 can be broken down into 2 times 2. So I'm going to take my grouping of 2 here, and I'm going to multiply it by the negative 3. Negative 3 times 2 is negative 6. So I have negative 6 root 3. Now once again, that 3 stays behind because it doesn't have a partner to mess around with. Next, I'm going to bring down my 3 root 3. Now, I can't simplify that at all, so I'm just going to bring it down, and I'm going to include that plus sign that's in front. So I have negative 6 root 3 plus 3 root 3. Now, lastly, we need to take a look at our 3 root 20. So, 20 can be broken down into 4 times 5, or 2 times 10. Either combination works. And then next, 4 is 2 times 2. I have a pair of 2s that I can move up and combine with my 3. So that's going to be 2 times 3, which is 6. So I'm going to bring out a plus 6. And then my 5 is going to stay behind because it as well does not also have a partner. So what I'm left with is negative 6 root 3 plus 3 root 3 plus 6 root 5. Here, I can combine my root 3's together because they are the same. So I'm going to leave this as root 3, and then I'm going to have negative 6 plus 3. Well, negative 6 plus 3 is negative 3, so I get negative 3 root 3, and because my 6 root 5 has nothing else to combine with, it is going to stay as is at the end here. So our final answer is negative 3 root 3 plus 6 root 5. That is as far as we can possibly take that, so that is our answer. Now on the other side of this, I do have a couple more examples, and then we're going to get going with your assignment for today. If you have any questions at all, please pause this video, rewatch it. If you still have questions about simplifying these radicals, I will link the video here in the comments, so please make sure that you check that one out as well. So this way you are all set to go for this unit and the lessons beyond. Here we go. So to begin with, we are going to start out by practicing once again our adding and subtracting of radicals. Here I have negative 3 root 5 minus root 6 minus 1 root 5. So let's get this going. Let's first see if we can simplify any of these here. Remember, our first step that we always want to look at is simplify. So I'm going to rewrite those steps over here on the side. Okay. So my steps, once again, are to 1, simplify everything. So I'm going to simplify. 2, I'm going to add or subtract my like terms. Okay, and there we go. So we have 2 steps. 1, simplify. If we can't simplify, leave it. 2, add or subtract the like terms. So with negative 3 root 5, 5 is a prime factor. It's a prime number. The only numbers that multiply to get it are 1 and 5 or 5 and 1. So we can't break it down any further. So this one, I'm just going to bring down. I get negative 3 root 5. Next, here I have root 6. Because I have a single root 6 here, in order for it to exist, there has to be a 1 in front. So I can also add a 1 in front of my radical sign. Because say I have the variable x. In order for x to exist, one of them has to be there. So root 6 is the same thing as 1 root 6. Now 6 can be broken down into 2 and 3. Neither one of those have a pair. So we're going to leave this as is. So I'm also going to bring this down, and it's 1 root 6. Now, my root 5. Root 5, once again, is a prime factor. We can't do anything with it. So now that we've checked to see for our simplification and see if we can simplify anything, we're going to move into adding or subtracting our like terms. Here, my like terms include my negative 3 root 5 and my negative 1 root 5. My root 5s are going to stay the same. And then negative 3 minus 1 is going to give me negative 4. So I have negative 4 root 5. And then because my root 6 doesn't have a partner, it's just going to stay. So I have minus 1 root 6. I will also accept negative 4 root 5 minus root 6. Either one of these answers is correct. Okay, here we go. Number 2. Number 2 says negative 3 root 3 minus root 8 minus root 3. So let's check to see if we can simplify. Negative 3 root 3 cannot, so it's going to stay. I'm going to bring this down. Now I have negative root 8. 8 is not a prime number, so we can simplify it. We get 4 and 2. 4 can break down to 2 and 2. Now I have a pair of 2's here that I can move to the front, leaving me with a solo 2 behind. So I'm going to have 2 root 2, and that's going to be a minus because there was a minus sign already in front of it. And then here I have negative root 3. Once again, can't do anything with it, so I'm going to leave it as is. So altogether, I have negative 3 root 3 minus 2 root 2 minus root 3. Now once again, my root 3's, they are both root 3, so I can combine them together. And then this is negative 3 minus 1. In order for this root 3 to exist, there has to be one of it, so we can put that 1 in front. So that's going to be negative 3 minus 1, which would be negative 4. So I'm going to have negative 4 root 3, and then my negative 2 root 2 will follow. So my final answer is this here. All right. Next, number 3. I have negative 3 root 2 plus 3 root 20 minus 3 root 8. Throwing a lot of 3's here. All right, so here we go. So negative 3 root 2. 2 is a prime number. Can't do anything with it. Gonna draw the arrow, bring it down. 3 root 20. 20 is not a prime factor. We can go 10 times 2. We can go 4 times 5. I'm going to choose 4 times 5. Now 4 can break down into 2 times 2. My 5 is going to be left behind. I can bring this pair of 2's to the front, multiplying it with a 3. So now that's going to give me 6 root 5. And there was a plus sign in front, so I'm going to leave that plus sign there. Now 8, for my negative 3 root 8, 8 is not a prime number, so we're going to simplify it once again. I have 4 and 2. I get 2 and 2. This pair of 2's here can come up and be multiplied by my 3, leaving me with 2 times negative 3, which would be negative 6. And then my solo 2 is going to stay behind. Now I'm still once again going to bring down my negative 3 root 2. From here, I can combine my negative 6 root 2 and my negative 3 root 2. When I do that, I get negative 3 minus 6, which would be negative 9. So I have negative 9 root 2, and then my plus 6 root 5. That would be my final answer. Now, for our final problem today, I would like you guys to please pause this video, and then I would like you to give this one a shot on your own. This is going to be the highest level of difficulty that you will see on your assignment. So go ahead and pause this video, give it a shot. All right, so here we go. So, getting back to this problem, I broke down 45 because once again, our first step is to simplify everything as much as possible. 45 can be broken down into 9 times 5. You can also do 15 times 3. Either way, we're going to get a pair of 3s that will move out to the front. Now, once again, this is a negative in front, so in order for this to exist at all, there has to be a 1 right here. So it is negative 1 times 3, which is going to give me negative 3. My 5 doesn't have a partner, so it's going to stay behind. So I get negative 3 root 5. Next, 2 root 5. 5 is prime. Can't do anything with it, so I brought it down. Moving on to the negative root 20. I have 20. I'm going to break it down into 4 times 5. 4 can be broken down into 2 times 2. I'm going to bring out this pair of 2's, put it in front of my radical, and that's going to leave me with negative 2 root 5. And lastly, I get negative 2 root 6. Can't do anything with this because although 6 is not a prime number, it's composite. 6 does not have a partner that it can move out with because we only have 2 times 3 or 6 times 1. So I'm going to bring that out and I'm left with negative 2 root 6. Now I have 3 groups of 5 here. So I have negative 3 root 5 plus 2 root 5 minus 2 root 5. Negative 3 plus 2, I get negative 1. Minus 2, we'll get negative 3. Excuse me. So we have negative 3 root 5 minus 2 root 6 because I can't do anything with this root 6. So I just bring it over. That's our final answer. All right, now for your assignment in this, I am going to ask you to do the odds. I forgot to put that in your instructions home. So if you're going to do this, please just do the odds. Here we go. So please make sure that your name, both first and last, goes on this assignment on both pages, please. We're getting some separation of the pages. I am recording this on Monday the 18th. And this is for class period 4. So once again, you are doing the odds only. Okay, so taking a look at this, I've got 1, 3, 5, and so on. So basically everything in that first column is what we will be completing. Now, for numbers 1 through 7, they're pretty easy. Their denominators are already the same. So this is just to get you, or sorry, not denominators, they're radicals. Their radicals are already the same. So this is just to give you some practice on initially combining these together. So, since my radicals are the same, 4 root 6 and root 6, I'm going to keep that root 6. And now I'm going to go 3 minus 4. That gives me negative 1. So I can either have negative 1 root 6 or negative root 6. Either one of those would be an acceptable answer. Next, number 3. I have root 21 and root 21, so I'm going to keep that root 21. And now I have negative 11 minus 11. Now negative 11 minus 11 is going to give us negative 22. So our answer is negative 22 root 21. Now, if for any reason this had said plus 11, we'd get 0. Now 0 root 21, that cannot exist. So when you get that, our answer is simply 0. Okay? Moving on to number 9. Okay, for number 9, we have 2 root 6 minus 2 root 24. We're going to check to see if we can simplify any of these. Now, root 6 cannot be simplified because it's just 2 times 3, but my root 24 can. So I'm going to simplify that. Now that's going to give me 4 times 6. You could also use 8 times 3. Either one of those is fine. 4 is 2 and 2. 6 is 2 and 3. Now I have a pair of 2's here that I can bring up and multiply with the coefficient of 2 that's already in front of this. What will be left behind, however, is this 6 because I'm just simply left with 2 and 3. So that's going to give me 2 root 6 from my original, which I'm going to bring down. I'm going to have 2 times 2, which is 4, so I'm going to be left with negative 4 root 6. Now we need to simplify this. So 2 minus 4, that gives us negative 2. And we're left with our root 6, so negative 2 root 6 is our final answer. If you have any questions on this at all, please leave me a comment, send me a message. I am here to help any way I can. Thank you so very much for watching. This has been Mrs. Ross Does Math.